Thank you very much. Super excited to be here. Just a quick note before we get started on the conferences front, since that seems to be a theme. Chef are running community summits again this year. The London one is on October the 12th and 13th. It's a mix of talks and open spaces. It was really good last year, I recommend it. And if you happen to be in Seattle at the end of the month, we're running a slightly longer one that also includes a Habitat Day. So yeah, there are cards about this outside as well. So I'm talking tonight about learning from configuration management. My name is Tom May, and I'm the community engineering lead at Chef. What that means in practice is that I'm sort of in charge of all of Chef's open source efforts in terms of dealing with pull requests from the community, working with our RFC process to add new features to Chef, and yeah, it's one of the best jobs I could imagine happening. Basically, I get to work on open source all day, and occasionally I do some real work. And at Chef, obviously, we quite like configuration management. We've been doing it a while. And so what this talk is not is, okay, you should all stop using configuration management. That was so 2000s. I was using Puppet a decade ago, I think now. I can't really imagine doing an operational job without it. And so that's the thing, that this talk is designed to take our learnings from configuration management and really take those learnings and talk about how we might apply that in spaces that are not so suitable for traditional configuration management. A brief history of configuration management. Did anyone ever use CF Engine? Has anyone used CF Engine? Okay, a few hands, cool. I guess looking at that list, I would say that Puppet and Chef and CF Engine were the traditional configuration management tools. But Salt, Stack, and Ansible are absolutely tools that apply configuration to a state. I think you might say that they're more of an agent that is event-based rather than policy-based, but they are absolutely configuration management tools. And again, console is the same. It's not how we might traditionally think of configuration management, but it takes configuration from your environment and applies it to a system or a set of systems. I think it's fair to say that configuration management tools have interesting learning curves. I certainly remember the despair and sadness of most of the tools I've used, and I've probably used them all. At times when you think, oh, this is really easy, I've got this nailed, let's apply what I've learned to a slightly more complex system, and then sadness and bulldozers. But I think the other thing that we're thinking about is configuration management is only part of a bigger whole. And what people as individuals have found as a learning curve of configuration management is also true of the industry for DevOps, for infrastructure management. All of these things have had steep learning curves. We've gone backwards as far as we've gone forwards a lot of the time. And I think it's really only now that we're in a position that we're actually really moving forwards. But now we're applying configuration management to all the things, right? There have definitely been jobs where the only thing I have done is configuration management. And if I had to do something that was not configuration management, that was likely a really serious break. Like I'm into an area where I should not be and where I do not want to be. So we're applying configuration management to everything. Is that a good thing? Well, it turns out that some of the things we're applying configuration management to, you're taking a bit of a wedge to, right? There are some things that maybe this is not such the most appropriate tool. So what could be better? Well, centralization is definitely a thing that, in one way or another, configuration management systems suffer from. Okay? In one way or another, we tend to have a single source of truth. Or if you're running configuration management on in a masterless configuration, then you have lots of single sources of truth. Which, well, maybe is not the best. It doesn't, for configuration management, it's not necessarily a problem that you have a centralized system. If your configuration management system goes down, if your configuration management server goes down, that's not necessarily an immediate problem for the running of your production infrastructure. It becomes a problem the instant you need to make a change to your production infrastructure. But that does not mean it's a severity 1 incident immediately. It is a severity 1 problem, but you have time, right? So you can work around the centralization problems, but they still exist, right? Immutable infrastructure is the elephant in the room. If we want to talk about configuration management, then we're thinking about applying configuration management to a golden image, to something that we're then freezing and pushing out and running in our infrastructure. Or really we're just pretending that immutable infrastructure is immutable because of all the things that still change on a second-by-second basis. And even if we get to things that are closer to being immutable, like Docker, we still have to apply configuration to Docker. We have to deal still with running Docker in production, which is a kettle of fish that I don't want to dig into particularly right now. When you start doing configuration management, typically you take a part of a service and you get that into configuration management, and then you iterate, right? And you work your way through until you understand that the things that you care about are in configuration management. But at almost no point do you have every single system or every single file on a system completely under configuration management. I think it's pretty unlikely that you will ever see a system where every single Linux device file is being uniquely controlled in terms of permissions in a configuration management system. It's not viable, and it's unlikely ever to be. So generally, we just manage the deltas. We take a state that we know about. If that's an Ubuntu release, then we take our Ubuntu release, and we apply deltas, and we build those deltas up over time. So that's the theory. But in practice, how do we know exactly what version of OpenSSL is on every system? And how do we know which systems on that system have been restarted to pick up the new version of OpenSSL? We hope we know. We probably know for the things that we care about, but we can't, it's very difficult to prove that we know for all of the things that are running on our estate. And then there's orchestration. Either we have introduced another single point of failure in our infrastructure, which is the system that runs our orchestration tools, or our orchestration tools are running on your laptop. And then we have more sadness. There are, of course there are systems that deal with this stuff. You can engineer your way out of every problem. But there's a cost associated with that that is maybe not worth paying. So let's talk about choreography rather than orchestration. What do we mean by that? So in an orchestration system, actually, let's do this. Right, we're going to do some orchestration live in the room. So, when I point at your row, you're going to stand up. When I stop pointing at your row, you're going to sit down. Okay? Both sides at once, we're doing it. Cool. And then from the back, we're coming back again. And so one row at a time. Hannah, that's you. Up. And your row, obviously. And back, and back, and good. Okay. So that was orchestration. I've had to interact with basically every single one of you, with some exceptions, but it's a lot of effort, and all of the knowledge is centralized. It's much harder for me to go, oh, that node is taking a bit longer, let's delay everyone else, because I've already told lots of other people that this is going on. A better way of doing it would be for me to say, when the person in front of you stands up, you should stand up. Okay? And when the person in front of you starts to sit down, you should sit down. And we'll go from the front. And so there we go. I'm fine with this. You all could end up standing up for a long time. But yeah, so this is the point of choreography, right? I gave everyone the same instruction and then sent an instruction to start that process. I haven't had to know what any of the nodes are doing. If the person in front of you didn't bother standing up, then you might not have stood up. And that's okay, because that probably means there was a problem in the row in front of you, and we need to do something about that. So that's choreography. We're pushing the information that our system needs down to the individual nodes. We're no longer centralizing it. We're pushing intelligence and automation out to individual nodes. Okay? Excuse me. So, back to the things that we could be better. Application release patterns. How do we release applications using configuration management? In general, you're looking at things like, in the old days, Capistrano, maybe using Docker, or something like Kubernetes, or Swarm, or Nomad, but we're still having to drive how things get into those systems, right? Each application is almost its own special snowflake, unless you do the engineering work up front to ensure that it's not. And this comes down to tool chains as well. Unless you've done the abstraction work to say, actually, all of my tool chains are just driven by Jenkins with a script in a known location, you still have to think about how each platform and how each service and how each system is released. And then you start adding more tools to that process. You add console, or you add a scheduler, or however that works. And all of the time we're adding complexity to our infrastructure. But what would it look like if we built for choreography instead of orchestration? Let's take an application. So we've got a database, a Java application server, and Nginx in front of that. So we decide to do an upgrade on our database. In this model, our database is going to tell our application server, hey, I'm going down to do an upgrade. Our application server now knows how to apply logic to say, okay, in this situation, I'm going to shunt users to a backup server, or I'm going to shunt users onto a landing page that says, hey, we're down for maintenance. And again, it can then tell Nginx, maybe serve a static page so that we take the load off the system altogether. All of those things happen organically in the system, that it's all able to be controlled by the systems themselves rather than by the users. And so now our database server has finished its upgrade, and so it communicates to our application server, hey, I'm back online. And our application server communicates that same thing to Nginx. So we're thinking about building for distributed systems here. We're not thinking about building central points of truth. We're not thinking about individual systems so much anymore. We want to be able to run immutable systems because there are a huge number of benefits from doing so. But we also want to be able to push configuration to those systems. We want to be able to say, we've changed the location of a database server, or we've moved a fit because reasons, without having to recompile our entire estate. And we want to be able to talk about and to reason about what our dependencies look like and what our tool chain looks like, so that we can say with certainty, okay, this application is running a safe version of OpenSSL. We've upgraded to the latest Java so that we're not vulnerable to whatever horrors have lurked in the previous Javas. And we're going to do all of these things exactly the same. So that's Habitat, we think. It's an application development and deployment framework that builds in a choreography system to allow it to maintain and run applications. This doesn't mean that configuration management is dead. These are very complementary things. We think that configuration management is great for running your infrastructure. It's great for getting your systems into a known state and for keeping them that way. But for deploying applications, we think there is something that we can do better. And so let's take a look into Habitat. The first component is the studio, which is a clean room that allows you to safely build packages and applications that have a totally known state, so they're not reliant on any part of your operating system. And then we have plans which define how those applications are built. And so at this point, I'm going to give myself over to the live demo, and hopefully we'll see how this goes. So, can you see the text on there? Yeah? Back? Good? Yeah? Cool. So, I'm going to talk about the Redis package because it's a relatively self-contained system that we can show most of the interesting things. So this is the plan for Redis. And let's take a look. Let's take a look at that plan. Sorry. So the interesting things here, name, version of Redis that we're interested in, where we download Redis, the build dependencies of Redis and the actual package dependencies, and this is how we're going to run the system. Redis is very simple, it just requires you to run make. So that's how we build our application. We also ship a templated config file. This is handlebars, so if you've seen handlebars before, this is a variable. And a conditional here. And so we can make decisions in the template based on what Habitat tells us. We can also configure leader and follower servers, and so yeah. So that's a config file. And then we ship a set of defaults for that config, which is a key value system. So let us go into a Habitat studio. So I'm just going to type build, wrong directory. Let's try that again. Okay, so like I said, this is a clean room, so it's downloading. Oh good, the internet's fast. That makes life easier. It's downloading the dependencies for Redis and then working its way through the dependency chain. And yeah, so we're compiling Redis, and this is generally quick. I bet you didn't think you would come here and see a whole bunch of C compiling tonight. Yeah. So once this is done, we'll have a package. And boom. Right. So we just built Redis, and we just created ourselves a Habitat archive. So, great, you say, what happens next? Well, for the purposes of this demo, we're going to export that archive as a Docker container. So we'll just say export to Docker. It's using so there's a namespace for each package. So most packages are available in the core namespace, which is something that Chef maintains. But because I just built that, it's put it in my namespace. So let's export this to Docker really quickly. I hope pretty quickly. Probably more of you have seen Docker. So if I now do Docker images, scroll up a bit, I just built Tom/Redis, that tag 9 seconds ago. And I can run it. Okay? So that's Redis running underneath a Habitat supervisor. So what does that actually mean? Why do we care? Cool. And you can upload your application packages to a Habitat depot. Sorry. Yeah. Okay. So the depot is also open source, so you can run it yourself, and we would recommend doing that for internal applications. Now, Habitat provides a runtime as part of it, which is a supervisor. That allows you it gives you service discovery in that it can find other Habitat supervisors on the local network. It gives you configuration management in that you can inject configuration to the supervisor, which will then pass that on to the application running underneath that supervisor. It also gives you health checks and process management so that it can take care of restarting applications if they crash, but also starting and stopping for upgrades. So let's move back to disclaimer back on for a second. So if we look here, this line says TCP backlog setting can't be enforced because the default is set to 128. So in a traditional Docker container, what would we do to deal with this? Probably we would rebuild that Docker container. So if we So to give you a quick view of how this works, we will we'll pass in a configuration option via the environment, and we can see that the warning is gone. Okay? So what we can do next is pass that same. We'll turn this back on so that the error is there again. And over here, hopefully, we can send that same configuration to a running container. So here we see Habitat has received a gossip message from the other system. It's stopped Redis, it's applied the new configuration, and the message is gone. So you can do that live to systems that configured protected mode, which is a new bit of configuration. But that's cool because we can turn it off by sending a gossip message. And so now we have a working 3-node cluster. Okay, so that hopefully gives you a bit of an overview of what the supervisor is able to do for us and why we think this is so powerful. You can put multiple supervisors in a ring, as we did there, and that gives you the leadership election. It also gives you a way of sending upgrade messages, so you can say, I've got a new version of Redis, please upgrade to it. And while this functionality hasn't been written yet, you would then be able to do A/B upgrades because the supervisors can schedule themselves to do single nodes at a time upgrades, to only do those upgrades if the previous node worked. And all of those things are enabled by the intelligence in the supervisor. We also have a REST API in there to allow you to do health checks. So you can ask the supervisor the status of the node, the status of the gossip ring. That's a bit of a long slide. This really is the thing that we're thinking about. The Habitat is application automation that travels along with the application, and it allows you to build applications that work in any environment without the need to rebuild those applications. And Habitat is open source, so you can download it, try it, use it. Thank you.
Awesome. I think the demo gods are smiling at us there. That's some really, really cool stuff. Anybody have a question for Tom? By the way, we've got some IBM Bluebeaks t-shirts, so who asks a question, and it's a good one, and I'll be the judge of that, and Jack will be the judge. So who's got a question? Raj.
Well, my question goes back to one of the very last things that you said, where the deployment will stop at a point where a node detects the previous node didn't function. How do you then ensure that you don't end up running disparate versions of the application across a cluster? Is there an automatic rollback facility?
So we're talking about things that do not yet exist. Okay, so this is a forward-looking statement.
Yeah. Have you considered that?
Yes, absolutely. And so one of the things that you might think about is if you detect such a situation, the supervisors could say, okay, we've got N nodes that are broken up and on a new version. We've got a smaller number of nodes that are working potentially on a new version, but we also have our old deployment. And so what we want to do in that situation is turn off all of the applications that are running the new version. And that would be something that you could do with the gossip player. Like that is absolutely something that would work. Yeah, you would need to build that logic, but that is something that we would help you do, and that we were thinking about.
Cool, that one was worth a t-shirt. Well done, Raj. I think Tom deserves another t-shirt for the answer. Next.
Excuse me, my possible stupid question, but after your quite long presentation, I did not understand how Habitat is related to Chef. Is it a wrapper? Is it a shell? Is it or it's absolutely independent product?
It's a completely independent product. The reason Habitat exists is because we kept seeing the same patterns for people trying to deploy applications with Chef and without Chef. And we were seeing the same things over and over again, like the same way people were trying to build application deployment systems. And so Habitat is an attempt to take a completely new, it's a completely clean code base. It's existed about a year or old, and yeah.
So in this case, can you compare these two products, Chef and Habitat? What is your advantage?
We think that Chef is for infrastructure management, and we think that Habitat is for application management. So you would deploy your systems, and you would probably deploy Like, there's a grey area in the middle when you think about DNS servers or things like that. So you might deploy them with Habitat, or you might deploy them with Chef. But applications are, you want to think about using Habitat, and infrastructure, the underlying infrastructure for those systems is Chef.
Well, that was cunning. That was 2 questions. You don't get 2 t-shirts now. Simon.
While you were talking through, it kept taking my mind to Cloud Foundry and PaaS. So I quickly Googled and it says you can run Habitat on PaaS. So
Yep.
if you could just elaborate in terms of,
Yeah,
is
so-
Habitat going towards a PaaS, or is it, how does it fit into a PaaS sort of environment?
No, we've been running Hab packages inside of Docker, as all of my demos were. You can deploy Habitat packages to a Mesos cluster. You can deploy to a Kubernetes cluster. So they again are complementary technologies. Like it's completely reasonable to think about scheduling your applications onto machines using code or something else, and then configuring and those applications being Habitat applications, so you can configure them and upgrade them and manage their life cycles using Habitat. So that, yeah, they're complementary rather than competing.
One more question for Tom. Oh, all the way at the back.
Something you didn't quite cover is that's an instance of Redis, whatever. We run a bureau type organisation, so we will have an image that will do something like Redis or something like that, but we'll have different roles for that, so it belongs to a client. And you didn't mention anything that would include like security between those layers. So any particular container for one particular client must not have credentials for any of the client's data or anything.
Indeed. I didn't touch on encryption because it's a long topic and this was a short talk. You can absolutely have configured encryption on the gossip layer itself, so that all of the messages between nodes on those gossip layers are encrypted, and so you can configure different keys for different parts of the infrastructure for different clients. Yeah. So.
Well, do we have one more question over here? I saw. Yeah, okay, just one more.
You mentioned that you can upgrade through supervisor, but I'm thinking in the example you gave us, it's a Redis container. If you have a new version of the application, how you would deploy that to a container? Would then rebuild the container and redeploy it? Or would it deploy a file in the container?
Yes, in the container case, you would undoubtedly upgrade the container and do it. If you were running bare Habitat packages inside of systemd, which I think is the way we're going to see quite a few people run these things, then they would take care of managing their own life cycle.
Cool. Tom May from Chef, thank you very much.